Welcome to the 3.1 notes for reflections. This is for Mrs. Ault's students. So kind of while we're looking at this one, there is a little exploration that I'm going to encourage you to do. So, in fact, I believe this exploration is sent to you on Teams. So you might want to get on Teams and take a look. I'm going to get there myself. So I'm going to pause this and move over to that GeoGebra link.
Love you, baby.
All right, so welcome back. Sorry, I was talking to my husband. You may have heard him. Okay, so we've got this shape. Now, your shape might look different than mine. Okay, you can take these points. You can move them around however you'd like. And what I'm going to do is I'm going to click this button that says Reflect. And I want you to just take a look at how this shape changed. Where is point A originally compared to point A now? Now you might notice this little apostrophe. We call that A prime. B is moved to B prime. I'm going to actually draw on the mirror line so you can see. This is the line that I'm reflecting over. How does it look when you reflect this line? Now something that you should do on your own is just kind of move some of these points around. Watch how they move in the reflection. What does the reflection look like? Now, something else you can kind of do if you're real curious is you could change how the reflection line looks if you'd like. You could even change it so it's now a horizontal line. And how does this change the reflection? Maybe I'll move some of these points. Maybe I'll move this horizontal line a little bit up. I'm actually even going to move this so that my horizontal line is now the x-axis. And as I move these, what do you notice about these points? Not just how it looks, but why don't you check the ordered pairs? Where's A to start off with? Where is A when I reflect it? Where's B to start off with? Where's B when I reflect it? What's changing? Be curious here. Ask yourself, what has changed? What has changed? What has stayed the same with each of these points? I'm just moving them to whole number answers just to make it a little easier for you to see the pattern. So I'm hoping that what you're seeing here is that this reflection turns it upside down. It's flipping it over when you reflect something. And look at the x-coordinates. The x-coordinates have all stayed the same for all of these. The y-coordinates are almost the same. The only thing that's different is the sign. Now what I'm going to do now is I'm going to change my mirror line a little bit. I'm going to make it a vertical line again. I might even move it so that it's the y-axis this time. And I'm going to move a couple of these points because this is just a little bit messy. I'm going to even move A to look like that. Okay, how does this change this time? Again, it's flipped over. And this time it's flipped from being the right side of the mirror line to the left side. And let's look at point A. Point A is really unusual. Notice that point A didn't change. That's because it's right on the line. However, if I moved point A away from the line, you will see that A did in fact change. What stayed the same for all of these lines, or for all of these points, is the y coordinate always stayed the same. The x coordinate changed. It changed signs no matter where I move these two. Interesting. So this is kind of what we're going to learn to do today. We'll learn to do this visually, but we're also going to learn how to do this without even maybe a graph. Transformations. Think about like Transformers, the movie Transformers. Not sure if you ever watched Transformers as a child, but like the robots in disguise or the movie. The TV show's way better than the movies, in my opinion. But what a transformation is, it's when a shape is changed. Okay, it's when you take a shape and you change it. There's different ways we can transform shapes. And when we change it, we result in an image. Okay, so let's just go back to that exploration really fast. Hopefully what you noticed when we did the type of transformation that it's a reflection is that it would flip the shape. Sometimes it would flip it upside down, but it would flip the shape over. It could be left or right, flipping or up and down. And hopefully something that you notice the same is it's the same size. It's the same size, but something that was different is the ordered pairs. Because it was flipped around, things got changed a little bit. There's 4 main types of transformations we're going to look at, 3 of them in this unit and 1 of them not till semester 2. The first type is the reflection, that mirror image that we were just looking at. The second type that we're going to look at is called a translation. We'll learn all of these terms. The third type is called a rotation. And then the fourth type we're not going to learn until semester 2, but this one is called a dilation. Like if you've ever been to the doctor's office and they've dilated your eyes, dilated the pupils of your eyes. So a reflection is where a shape is flipped over a line. Oops, I almost said a bad word. And so when we take a shape and we flip it over a line, we're going to start off with an original shape. The original shape is called the pre-image. The new shape after you flipped it over is the image. Now, when you're looking at a picture, you're going to be able to tell what the original shape was and what the pre-image was, the new shape, by looking at the notation. Again, the pre-image is the original shape before the transformation happens. The image is the shape after. The way you're going to be able to tell which was the original is that it will not have the little apostrophe. The image, the new one, will have this little apostrophe. A will become A prime. B will become B prime. C will become C prime. And reflections have that flipping motion. So some of these are reflections. Things are flipped over. Some of these are not. Go ahead and take a look. If you think any of these are reflections, you see the flipping shape, circle that letter. There's more than one. Okay, the ones that I'm seeing that look like reflections, A, that's flipped over. The line that it's flipped over is right here. B does not look like it's turned over or flipped over. So I'm not going to pick that one. C is flipped over. There's probably some like mirror line right here. It's turned upside down. So it could be turned left, right, or upside down as we're looking at this. D does not look flipped over. It looks more like it was a turning shape. That's something different. E, this looks flipped over. Look at the kind of like little eye of the fish. See how it's kind of turned upside down? F does not look like it's flipped over to me. It looks like it's just like a sliding motion. So I'm not thinking it's F. All right, example 2. This is something that you'll be doing on your homework. Okay, like examples 2 and 3, you're going to do this on your homework. We're going to take this figure and we're going to reflect it in the x-axis. Some people will write in the x-axis. Some people will write over the x-axis. It's the same thing. It's the same thing. All right, but when we're talking about reflecting it, it's that flipping motion. I think it's really important to kind of notice and maybe even highlight which line you're flipping something over with. Basically, what we're going to do is if you're starting above this line, you're going to end up below this line. The easiest way to reflect a figure is to reflect one point at a time, just those corner points, just those vertices. I'm going to start by doing this visually, and then we're going to fill out the pattern below. A right now is 2 units above my line of reflection. I'm going to place it 2 units below, and when I do that, I'm going to name that A prime. B currently is 1, 2, 3, 4, 5, 6 units above my line of reflection or my mirror line. I'm going to make it 6 units below. 1, 2, 3, 4, 5, 6. I'm going to name that B prime. C is currently 2 units above. I'm going to make it 2 units below. Notice I'm not moving it Left or right, I'm just flipping it above or below. Now, some people really don't like these little lines, so I'll erase that. That's fine. I don't care if you have them, but some people just really dislike them. And then I'm going to connect my shape. Now, my shape should still be a triangle. It should still be the same size as it was before. It should just be turned upside down, flipped over. So part of what you're going to do on your homework is you'll be drawing reflections. And when you draw them, please make sure your image, the new shape, has the prime notation for each ordered pair. Now the pattern. A was at the point -5, 2. -5, 2. When you're naming points, make sure you go to the left and right first, up and down second. This is the opposite order of slope. Where is A prime? A prime is still to the left 5, but it's now 2 units below the x-axis we went down to. What's the same? What's different? B. B was at the point -2, 6 to the left 2 and up 6. Where is B prime? It's also to the left 2, but it's down 6. It's at -2, -6. Compare those ordered pairs. What's the same and what's different? C. Point C was at 3, 2. C prime is at 3, -2. Well, when you reflect things in the x-axis, what happens is that the x-coordinate stays the same. How do you spell? The x-coordinate stays the same, and the y-coordinate changes signs. It's still the same number for the y-coordinate, just with the sign change. I'll be real honest with you, there's patterns for all of this, but there's so many patterns. Most students don't do a really great job with memorizing the patterns. Most students do better by visually doing the transformation, doing the reflection on a graph, and then writing the answer. However, some of you are really good at memorizing, and so if you want, you can memorize the pattern for reflecting in the x-axis. Let's take a look at example 3. This time we're reflecting in a different axis. We're reflecting in the y-axis or reflecting over the y-axis. Either way of describing that is considered acceptable. So this time I'm starting to the right of my line of reflection. When I flip this over, I'm going to end up on the left side. Make sure you're reflecting over the one it says, because it looks different if you reflect over the wrong one. So I'm currently, point A is 2 units to the right of my mirror line. I'm going to go 2 units to the left and call this A prime. It's up to you if you want to keep those little lines there. B is 1, 2, 3, 4, 5 units to the right. B prime would be 1, 2, 3, 4, 5 units to the left. C is 1, 2, 3, 4, 5 units to the right. C prime would be 1, 2, 3, 4, 5 units to the left. And then I'm going to connect these points. I'm just reflecting the vertices, and then I will redraw the triangle. When you compare these triangles, this should be the same triangle on the right and on the left, just flipped. If I write the ordered pairs, A is at 2, 4. To the right 2 and up 4. A prime is at -2, 4. B is at 5, 6, if I counted right. B prime is at -5, 6. C is at 5, -2, and C prime is at -5, -2. Now you'll have to, on your homework, list the ordered pairs of the image on your homework. Little typo here. Make a conjecture about reflecting in the x-axis. This should actually say the y-axis because that's what we did in this problem. Well, what's the same and what's different? When you reflect in the y-axis, the y-coordinates stay the same. You're reflecting in the y-coordinates stay the same. But the x-coordinates change signs. This is the opposite of what happens when you reflect in the x-axis. Because the image triangles are the same size and the same shape as the original one, we can say that this is called a rigid transformation, which basically just means that the image and the pre-image are congruent. They're the same size and shape. If it's a rigid transformation, we're not changing the size and shape, we're just maybe flipping it over or moving it, if you will. Now, we're going to look, the next part of this lesson, we're going to be reflecting sometimes in lines that are not the X and Y axis. They're other horizontal and vertical lines. So it's important that we know how to graph those so that we can do this properly. Horizontal lines are always going to be of a certain type of equation. I'm just going to graph a horizontal line. Let's just graph maybe this horizontal line right here. To see what the equation is, let's look at a couple points. This point is 1, 3. This point is 2, 3. This point is 4, 3. This point is 6, 3. This point is -3, 3. This point is 8, 3. What I want you to notice about this line, this horizontal line, is that the X values are going to change and be any number, but the Y values will always be the same number, 3. This is the line Y, whoops. This is the equation of this line is Y equals 3. X can be anything you want, but the Y will always stay 3. A horizontal line will be in the form Y equals some number, and that number will be the height of the line. Vertical lines. If I draw a vertical line, maybe I'll draw one right here. And if I look at the ordered pairs of some of the points on the line, this is 2, 5, 2, 4, 2, 2. I'm skipping a couple. 2, 0, skipping a whole bunch. 2, -3, 2, -4, 2, -6, and so forth, right? There's an infinite number of lines. The thing that stays the same, we can have any Y value, but for a vertical line, they're never going to move right or left from that 2, and it's always going to stay with an X value of 2. So vertical lines have the equation X equals some number. X equals some number. So this is a little bit tricky because I know that when we're looking at our X and Y axes, the horizontal axis is X, but the equation of a horizontal line is Y equals. It's opposite. Confusing. Okay, and again, it's because they all stay at the same Y coordinate for their points for a horizontal line. A vertical line, I know the vertical axis is called the Y axis, but the vertical line is X equals some number because they all stay at a certain X value for those points. So here's how you might need that. The last part here, and this is all just kind of the same thing, we're just doing some practice here, is that you're going to be reflecting lines, but they're not going to be in horizontal and vertical. They're not going to be along the X and Y axis. This line, Y equals 1, Y equals a number, is a horizontal line. This line goes like here. We're going to go on the Y axis to 1, and I'm going to draw a horizontal line. And now I'm going to draw in the image here. A is 1 unit above this, so A prime would be 1 unit below my green line. Not reflecting over the axis this time. B is 1, 2, 3, 4, 5 units above the green line, so it would be 1, 2, 3, 4, 5 units below the B prime, the green line for B prime. C is 1 unit above, C prime will be 1 unit below, and then I can draw in my triangle. The last thing I would need to do on this problem is list the coordinates of the image. A is at -5, 0. Notice my x-axis is still here. I'm still naming points by my x and y axes. B is at -2, -4. C prime, or that was B prime, pardon me. C prime is at 3, 0. Number 5. This time I'm reflecting in a line that's x equals. This is a vertical line. I'm going to draw the vertical line x equals 1. I'll go on the x-axis to 1 and then draw a vertical line. This is kind of an interesting one. Let's just start with the point x. X is 2 units to the right of my mirror line. So I need to move 2 units to the left for X prime. Oops, I didn't mean to move away my line of reflection, sorry. So X was to the right of this line, so its image X prime was to the left. The thing that's weird about this one is that X and Y are on different sides of my line of reflection. Our X and W. W is 1, 2, 3, 4 lines away, 4 steps away from my line of reflection. So I'm going to make W prime 4 units away to the right. And then I will connect these points. X prime, W prime should look like the original segment, just flipped over. Sorry, trouble drawing. And then what are the coordinates? Well, X prime is at -1, 4, to the left 1, up 4, opposite of slope when you're naming points. And X prime, oh, that was actually X prime, sorry. And then W prime is from the origin, 1, 2, 3, 4, 5 over to the right and up 1. So I'm going to pause the video. You try the next 4, and when you're ready, you can restart and compare. Well, all right, so here are my solutions. On the first one, since we're reflecting in the y-axis, most of the original triangle was to the left. P and Q are to the left of the y-axis. Notice they flipped over to the right. R was on the right side, it flipped over to the left. Please check your ordered pairs, make sure you're naming them properly. This is something that sometimes students struggle with. Example 6. When we reflect over the x-axis, we're going to move from above to below, or vice versa. This time we're above. All the points move to below. Please check those coordinates. Make sure you're naming those points properly. Example 8, the line x equals 3 is a vertical line. What was interesting about this one, W was to the left and so it flips over to the right side, but X was on the original vertical line of reflection, so X prime did not move. If points are on the actual line, they stay there. And so that's what happened with X prime. It didn't move from X. Number 9, y equals -2 is a horizontal line. So DE was above that line. So D prime, E prime would be below the line. And again, check your ordered pairs. That is the end of this lesson.